네, 안녕하세요. 네, my name is AJ. I'm a co-founder at Radius. Actually, we did a grant program of Ethereum Foundation called MEV-resistant AMM a few months ago. So today's talk is about the result of the program. So what's MEV? You probably heard a lot about MEV, but MEV is maximum values that can be extracted when building a block by censoring or inserting transactions or changing the orders of transactions in a block. So we hear a lot about MEV in blockchain and DeFi space, but the history actually goes back to traditional finance. Michael Lewis wrote a book called Flash Boys to tell us that how maliciously Wall Street institutions use insider trading information to make a huge profit at the expense of regular trade. So, for example, if you want to buy an Apple stock, your trade doesn't go directly to exchanges. Some entities called high-frequency trading firms sees your transaction first and then they buy all the Apple stocks at the exchange. So you will probably end up buying Apple stocks with higher price than you expected. So, and then this kind of user fund stealing was brought up to media again a few years ago with Robinhood. When Robinhood came into the market, it attracted millions of users with commission-free stock trading. But actually, the Robinhood make a profit by selling your trade to high-frequency trading firms that runs dark pools to front-run your trade. So that's why they can provide some kind of the trading fee-free. And then, so actually they manipulate your transactions to make a huge profit. So the key point that I want to emphasize from these examples that if there is anyone who knows trading information in advance and is able to change the order of transaction, is actually has a power to steal another person's money. So MEV is also happening in blockchain space. The set of transactions on the screen shows that the most common type of MEV, which is sandwiching attack. Sandwiching occurs that an attacker places two transactions before and after unopened transactions. We call it a victim to make manipulate price and to take profits. So I brought some statistics on the sandwich attack. More than 1,000 transactions are attacked on daily basis, and then MEV searchers or miners actually can make a huge profit from them. The more important thing is that users pay more. When they trade, users pay more than they would have without being attacked by sandwich attack. Ranges from as little as 2% to at most 87% of your trade. The worst part is that actually people don't realize that this type of MEV attack actually happens. So they actually, it leads to financial losses on your assets. So, but there are certainly a harmful effect of MEV, but there are also alternative perspective of MEV having a positive effect. So there are two kind of different types of MEV been discussed recently. So malicious MEV, such as front-running and sandwich attack, are definitely harmful to users. They are just to take money from your pockets. And then benign MEV is harmless to you. It's actually an essential part of in DeFi space. So we are not trying to prevent all kinds of MEV. We just prevent the bad ones and maximize good ones. So yeah, a benign MEV such as the arbitrage or liquidation is the essential part in DeFi space. Bad MEV, the malicious MEV, we see that as the biggest threat on Ethereum, and especially layer 2 protocol as well, because layer 2 has the only single sequencer to make a block, so they has more power to censor or reorder transactions when they make a block. And we refer to hidden slippage, that you pay more when you are MEV attacked. So, and then as you can see on the graph, MEV extraction is growing at a significant scale. So you need to be aware of that. And also, users pay a really high transaction gas fee because of MEV. MEV such as compete each other with a high gas fee to take a good position to front run or take profit. So the users usually use a gas estimator. Estimator use this PGA inflated the gas thing. So you usually end up with paying a really high gas fee when they compete each other. So that's the result of, that's from the bad MEV. And then the worst part is that it actually affects consensus as well. If MEV, if miners or sequencers capture some kind of opportunity to make a huge profit of MEV, they might reorg transactions history to take the profit. So it leads to it encourages consensus instability. So that's why we see that the bad MEV is kind of a threat on Ethereum. Someone say that it's like a predator in dark forests. So our team's approach is that we want to bring a true information symmetry to create a fair trading environment. So like in traditional financial system, we had to accept what was given. Trading systems aims for efficiency, and so that's why we give all the authority to centralized institutions for the efficiency of our trade. But ironically, we are forced to pay some kind of tax due to the exploitation on our trade, high frequency trading that I just mentioned before. So in blockchain space, we have the choice to what's right. So that's why we want to build some kind of fair trading environment to bring a true information symmetry. So I will explain our approach to make. So as I said before, MEV is all about the ordering of transactions. MEV happens because your transactions is open to anyone. So the naive way to prevent MEV is that just encrypt your transactions to hide it from MEV attackers. But if transactions are hidden, the problem is that the transaction is hidden, the global state also unknown. So it's really difficult to make transaction with unknown states. So that's why people say that it's kind of difficult to make private Uniswap. So that's why we came up with a delay encryption in which encrypted transactions are automatically decrypted after a specified amount of time. And before this time ends up, sequencers or miners have to confirm the transaction order without seeing the contents of the transactions. So that's how we build a fair ordering. And then to build a delay, we adopted a time lock puzzle. Time lock puzzle is just a specified number of sequential computation. So, and then the solution to this time lock puzzle will be used as an encryption symmetric key to encrypt transactions. But encrypting transactions leads to another problem, especially on the sequencer side. For example, malicious users submit encrypted transactions with invalid key with invalid transactions. The sequencers can't distinguish if it's invalid or not because it's encrypted. So that's why we need some kind of verification to prove that this encryption process is done correctly. So that's why we came up with some kind of validity proof with the ZK, the zero knowledge proof. So if with this ZK-based proof, sequencers verifies this proof, and then if verification is true, then try to solve time lock puzzle to get decryption key. Without this ZK-based validity proof, sequencers might waste their computing resources to solve invalid time lock puzzle. So. Okay, the boxes are checked for preventing the user funding stealing and prevention of DDoS attack on sequencer side. But generating this GK-based validity proof should be done on user's side with limited computing resources. So we need to make more practical. So that's why we come up with some kind of the tricks. And first, to delay. As I said before, the time lock puzzle is based on sequential computation. Actually, it's RSA, the hidden order group. So, but a user is the one who generates this time lock puzzle, which means they know what the hidden order is. So they use it as some kind of trapdoor to solve time lock puzzle really fast. So we said it's practical on the user side. And then as for validity proof, it turns out that it's really, it's almost impossible to turn those time lock puzzle and encryption into ZK snarks. So that's why we combine the ZK snark and Sigma protocol to make the generating validity proof process to be done on general MacBook in 5 seconds. So that's the result of the approach. So that's how we came up with the PVDE, practical verifiable delay encryption. The most important part is that on step 3, when a user submits transactions with a validity proof, a sequencer verifies this validity proof, and then if this verification is true, a sequencer responds to users with order commitment. It's some kind of a promise that your transaction will be included in a specified order in a block. And then users can make a claim when they find out that sequencers break the promise. So that's how it works. So let's deep dive into PVDE scheme. As I said before, we developed this scheme when we are doing a grant program of Ethereum. So thanks to OneSup and Barry Whitehead from Ethereum Foundation, we measured the proving time to generate this validity proof, especially a timeless puzzle in ZK circuit. So, and then we run it on the general MacBook, so you can see the specs on the screen. There are 4 approaches to make the timeless puzzle into with GKP to generate the validity proof. The simple way is that just to put the timeless puzzle function in ZK Snark's circuit. You can see that we are using the RSA-based the hidden order group. So to achieve 182-bit security, we need to set up generator G as a 2048 bits. And then if we want to make a 10 seconds delay, we need to set the specified number of steps, which is 2 to T, is 8 million bits, which is ridiculously large. So we can't make it to be integrated inside the circuit. So actually we failed to get some result. So we thought that okay, let's reduce the number of steps to make the timeless puzzle. So that's why we come up with the trapdoor. As I said before, the users know the trapdoor, which is the order of RSA group that is used to make the timeless puzzle. As the users know the hidden order group, hidden order, so we could reduce the steps for timeless puzzle, but it turns out that what matters is not the steps of timeless puzzle. Actually, it was the size of a variable for the steps to be stored in the circuit. So actually, we also failed. And then another one is actually we are getting the number for proving time. We tried to reduce the size of the variables for the steps to be stored in the circuit. So actually we run trusted setup. So we generate the parameter 2 to T, and then we used the number of steps as 128 bits as a secret value. So as easily can see that G to 2 to T to S is the same as G to S to 2 to T, which will be used as an encryption key. So, but as you can see in D, we still need to calculate the 2048-bit scaling 128 bits twice inside the circuit, which is why we've got the 540 seconds to generate proof. So it's you can see that it's not practical, especially on user's side. No one wants to wait for that amount of time to make a single Uniswap transaction. So that's why finally we actually managed successfully to generate this GK-based the validity proof within 5 seconds. As I said, it's difficult to just use only the GK Snarks. So we used not only Snark and also Sigma protocol. So finally make it, we think is practical. So we will tell you the details of the scheme after we are done with writing a thesis, and then also the previous experiment, the result as well. So okay, so another thing that I want to point out that is PVD scheme is actually agnostic, which means that we make separate the transaction ordering and transaction execution. So you can deploy PVD-based some kind of dApps on anything. So when we did our grant program, we actually built PVD-based DEX on Optimism. This is the architecture that we did at that time. So you can see that there's a transaction order management based on MMR and the order contract management as well. So, and then also a few months ago, we participated in a hackathon called the Hack Money 2022. At that time, we also built, we modified the Uniswap and deployed this MEV-resistant DEX without any hidden slippage on Polygon. So at the time also we had a great result as well. And then lastly, we published technical articles on Ethereum Foundation forum. So you can check out that. This is the ultimate goal of our project, which is the MEV-resistant ZK rollup with PVDE. MEV is happening not only in DeFi space, but also actually in happening NFT and bridges as well. A few months ago, actually, the Bored Ape NFT is attacked by MEV as well. So that's why we want to build some kind of ZK rollup. I mean, the ecosystem, not just only one specific type of the dApp. Okay, so this is the end of my talk. If you are interested in MEV resistant or PVDE and or the ZK rollup, please leave a comment on the articles on Ethereum Foundation, or just contact me, our team at the Radius. We believe that some people say MEV is inevitable, but we believe that MEV is not inevitable if we choose to prevent it. Yeah, thank you.